that's why you're having issues, that's something that is excusable. Okay, I can't put that in. That's something your parent would have to call the front office about. But that is a way around it. So, if the reason that, you dropped out of the meet or something happened because of your internet connection, you do have that option for your parent to call and excuse it through the front office. That is an excusable reason. Okay, so we're up to 16 so far. And I'm going to go ahead and get started on this. I can still see there's like 3 of us joining. All right. And so I'm just going to kind of read through what we're doing today. We are graphing systems of linear inequalities. Okay, this comes from lesson 12.2 in your text. And your EQ is how do you solve a system of linear inequalities. Your learning goal is I can graph the solution set to a system of linear inequalities into variables as the intersection of the corresponding half planes. So we're going to take what we've already been working with, where we graph one linear inequality in the coordinate plane, and we're going to actually be graphing 2 linear inequalities in the coordinate plane. Now, when we do that, you're going to have like half of it shaded one place and half of it shaded somewhere else, and you're going to see there's going to be some overlap. All right, and that overlap area is going to be what represents the solution set, because it's going to represent more than one ordered pair. So I'm going to show you a video, okay? And this is like a general introduction to how to do this, and then we'll go through some slides together.
Graph the solution set for this system. And it's a system of inequalities. We have y is greater than x minus 8, and y is less than 5 minus x. So let's graph the solution set for each of these inequalities. And then essentially where they overlap is the solution set for the system, the set of numbers that's, or the set of coordinates that satisfy both. So let me draw a coordinate axis here. So that is my x-axis. And then I have my y-axis. And that is my y-axis. And now let me draw the boundary line, the boundary for this first inequality. So the boundary line is going to look like y is equal to x minus 8, but it's not going to include it because it's only greater than x minus 8. But let's just graph x minus 8. So the y-intercept here is negative 8. When x is 0, y is going to be negative 8. So just go negative 1, negative 2, 3, 4, 5, 6, 7, 8. So that is negative 8. So the point 0, negative 8 is on the line. And then it has a slope of 1. This is you don't see it right there, but I could write it as 1x. So the slope here is going to be 1. I could just draw a line that goes straight up, or you could even say that it'll intersect if y is equal to 0. If y were equal to 0, x would be equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And so this is x is equal to 8. But it has a slope of 1. For every time you move to the right 1, you're going to move up 1. So the line is going to look something like this. And actually, let me not draw it as a solid line. If I did it as a solid line, that would actually be this equation right here. But we're not going to include that line. We care about the y values that are greater than that line. So what we want to do is do a dotted line to show that that's just the boundary, that we're not including that. We're not including that in our solution set. Let me do this in a new color. So this will be the color for that line, or for that inequality, I should say. So that is the boundary line. And this says y is greater than x minus 8. So you pick an x, and then x minus 8 would get us on the boundary line, and then y is greater than that. So it's all the y values above the line for any given x. So it'll be this region above the line right over here. And if that confuses you, I mean, in general, I like to just think, oh, greater than is going to be above the line. If it's less than, it's going to be below a line. But if you want to make sure, you can just test on either side of this line. So you could try the point 0, 0, which should be in our solution set. And if you say 0 is greater than 0 minus 8, or 0 is greater than negative 8, that works. So this definitely should be part of the solution set. And then you could try something out here like 10 comma 0 and see that it doesn't work. Because you would have 10 minus 8, which would be 2, and then you'd have 0, and 0 is not greater than 2. So when you test something out here, you also see that it won't work. But in general, I like to just say, hey, look, this is the boundary line, and we're greater than the boundary line for any given x. Now let's do this one over here. Let's do this one. The boundary line for it is going to be y is equal to 5 minus x. So the boundary line is y is equal to 5 minus x. So once again, if x is equal to 0, y is 5. So 1, 2, 3, 4, 5. And then it has a slope of -1. We could write this as y is equal to -1x plus 5. That's a little bit more traditional. So once again, y-intercept at 5. It has a slope of -1. Or another way to think about it, when y is 0, x will be equal to 5. So 1, 2, 3, 4, 5. So every time we move to the right one, we go down 1 because we have a -1 slope. So it will look like this. And once again, I want to do a dotted line. I want to do a dotted line because we are, so that is our dotted line. And I'm doing a dotted line because it says y is less than 5 minus x. If it was y is equal to 5 minus x, I would have included the line. If it was y is less than or equal to 5 minus x, I also would have made this line solid. But it's only less than. So for any x value, this is what 5 minus x. 5 minus x will sit on that boundary line. But we care about the y values that are less than that. So we want everything that is below the line. And once again, you can test on either side of the line. 0, 0 should work for this second inequality right here. 0 is indeed less than 5 minus 0. 0 is less than 5. And then you could try something like 0, 10 and see that it doesn't work. Because if you had 10 is less than 5 minus 0, that doesn't work. So it is everything below the line like that. And like we said, the solution set for this system, are all of the x's and y's, all of the coordinates that satisfy both of them. So all the shaded in purple satisfies the second inequality. All the shaded in green satisfies the first inequality. So the stuff that satisfies both of them is their overlap. So it's all of this region in blue. Hopefully this isn't making it too messy. All of this region in blue where the two overlap, below the magenta dotted line on the left-hand side, and above the green magenta line. That's only where they overlap. So it's only this region over here, and you're not including the boundary lines.
Okay, so that video, he showed you an example, like very detailed, of how you would graph both inequalities and find the solution area. And so on this slide here that I'm showing you, it's kind of showing you the steps in a way that you would use to solve a system of linear inequalities with graphing. And so if you're given two inequalities, like we have here, the one in green and the one in pink, okay, and then first step, graph and shade the solution to the green one, which is what we have on the graph here. Okay, so this line, because of the +2, it starts at 2 on the y-axis. Because of the -2, the slope is up 2 and to the left 1. And then because of the symbol, greater than or equal to, the line is solid, and we shade above. Then step 2 is to graph the pink inequality. So that's what we have here on this graph. Because of the intercept, the y-intercept of -1, it starts here. And then the slope of 0 and 5/10 is the same as 1/2. So the slope is positive 1/2. And then that's our line here. Because of the symbol less than, it is a dashed line, and we shade below. Now the third step, after you've graph both inequalities on the same coordinate plane, is to look for the overlapped shaded region. Okay, so that's this dark green area. That's where the two systems overlap. So any point in this dark green area would represent a solution to the system. If a point falls in just the pink area, it's not a solution to the system. It's only a solution to this inequality. But any point that you want to say is a solution has to satisfy both the pink and the green inequality. That's why we can only choose points where they overlap. Okay? So here's your first interactive slide. And so remember, if you want to get your full attendance credit, you have to participate in the Pear Deck. So here is a graphed system of linear inequalities. We have a picture here. All right, there's two linear inequalities. A blue one, y is greater than negative 3x plus 5. And a red one, y is less than or equal to x minus 2. And so we are going to graph, and that's what we have here. The blue dashed line is the blue inequality, and we shade it on this side. The red solid line is the red inequality, and we shaded below it. And so from this, it is showing us where the solution is to the system. So what you're going to do is drag your star to anywhere completely within the solution to the system. Your entire star needs to be dragged to a point or an area that would represent the solution to the system. Your star cannot be outside the solution to the system. So there's lots of possible places to put your star. There's a lot of wrong places to put your star. So what you're going to do right now, and I have 10 of you have already done it, which is fantastic. I need the other 10 of you to go to your Pear Deck slide and grab your star and drag it to where you think the solution area is shown, completely within the solution area. Okay, I'm up to 14 out of 20 responses. Remember, guys, if you don't respond, then I think you're doing something else. You've ignored this meet entirely. You're off playing a video game. Okay, and that's going to reflect in your attendance code, and it gets phone calls sent out to you about that. So you need to participate. That's all I'm asking you to do. Drag a cute little star to somewhere on the picture. It's really not that difficult. Okay, don't be afraid to make a mistake. Just drag it to where you think the answer is. It doesn't show your response specifically. I'm going to show everyone's response at the same time. All right. So what I see here is I have some green stars in this purple area. The green stars that are completely contained in the purple area are correct. Okay. If you put your star in just the blue, just the white, those are incorrect. Okay, to be a solution, it has to be completely contained in this purple area. Now, I noticed too, a lot of you put your star right at the point of intersection of the two lines. So that makes me think that you're remembering about when we solve systems of linear equations. That is absolutely where the solution is. When you solve a system of linear equations, not inequalities, we're looking for a single point of intersection. This is different. So this, we're looking for an entire shaded area. That is the solution. There's an infinite amount of solutions for this system, and it's all the points in this purple area. The 0.50, the 0.6, -5, the 0.6, +3. I could even go to 6, +4 because it's on a solid line. I could not go to 3, -4. I wouldn't be able to use that point because this is a dashed line, but I could go to 3, -3 because that's within the purple. So you need to make sure your star is completely contained within the purple. Okay, now what I'm going to like you guys to do today, right now, and also with our Delta Math assignment that we're going to have later, is I'm going to have you use Desmos to graph the inequalities, okay? So right now, in your Pear Deck tab, you should see a split screen. So if you go to your Pear Deck tab, you should see the current slide of a system of linear inequalities and some directions in green. And then you should also have the Desmos graphing calculator open. So what I want you to do is to type both inequalities to see what the solution graphed would be. You're going to type on one line the first inequality of y is greater than negative x minus 2. And then on the second line, you're going to type y is less than negative 5x plus 2. And we're going to see what happens in Desmos. Okay, so I have 1, 2, 3, 4, 5, 6 of you that have already done this perfectly. And so the 6 of you that haven't done, you want to look at that purple area because Desmos has used one inequality as blue and one inequality as red on this slide. And so the purple area represents the solution to the system. Any point in that purple area is the solution to your system. And so if you're in the Pear Deck, this window is automatically open for you through the Pear Deck. You don't have to open up a separate tab for Desmos. Okay, so you can kind of see how that works, and we'll go over that more as we go through the Delta Math assignment, how we're going to use that. So go ahead and come back to our Google Meet tab. And we have a new question here. It says you can determine if a point is a solution to a system of linear inequalities by checking if it lies within the shaded area of the graph system. So on that last slide, when we graphed the two inequalities, the whole purple area was the solution. Yes, Mauricio, the whole purple area is the solution. So when we graph two inequalities, we're looking to see where these points would fall in Desmos. Okay, so we're going to kind of do this one together. All right, and so what I'm going to do is I'm going to open up the Desmos graphing calculator and share it with you. And I'm going to type in the two inequalities that we have on this slide. The first one is y is greater than or equal to. And you have down at the bottom this keyboard that pops up, and you can get your symbols here. Okay, y is greater than or equal to negative x minus 4. Okay, and so when I first type that in, that looks like the entire thing is red. But if I reset my zoom by clicking on the home, I can now see that it's not the entire screen. It's half the coordinate plane. So this inequality, this equation, if I was to graph it as an equation, is this solid line here, but it's an inequality that has half the equal sign. So I have it solid and I shade above. And then I'm going to type in the second inequality, y is less than 2x minus 2. And you guys do not have to also type this in. I'm doing it for you. Okay, so you're just going to use my image right now. Okay, and now I can see two graphed inequalities, two half planes, and there is a big overlapped purpley area. Okay, because there's the red or pink, there's the lighter blue, and then this either darker blue or light purple. Okay, so the double overlap where you have both planes, that is the solution area. So any point in here, there's an infinite amount of points in here, represent the solution to this system of inequalities. The point 4, 0 is a solution to this system of inequalities. The point 0, 0 is not a solution to the system of inequalities. The point -80 is not a solution to the system of inequalities. 9, 9. So here's 9. And you can change your zoom if you want to see the exact numbers. 9 and then 9 right here. That point, that would fall in there. Now, one thing you can do too is, say you don't remember exactly how to plot points. You can also type in an ordered pair and Desmos will plot it for you. So I'm going to do that for this problem. I'm going to type all of these in, -1, 4, and see where it pops up. Okay, -1, 4, it popped up right here. This is just in the pink, that's not the solution. Okay, so I can take that one off. And then Mauricio pointed out that 9, 9 is the solution. And so that's where you're going to drag your star to, because if I do type that in, and here it is. It's in the purple, completely within the purple. Now, if it was on this dash line, that would not be a solution. You can't have a point on the dash line. It has to be completely contained in here. Now, this other line is a solid line. So you could have a point that's on the solid line. That would be okay. You have points on solid lines. You cannot have points on dash lines. But anything in this purple area is the solution. You know, if you keep zooming out, I mean, it goes on forever. Okay, point 3,500, comma 1,500, that is part of the solution. These are all the numbers that work for this inequality. Okay, it's not necessary to zoom that far out. You can reset it quickly by just doing default zoom, the home. All right, so drag your star to the correct ordered pair. We just did it together. Go to your pair deck tab. What is the solution? What point represents a solution to this system? I have 14 out of 23 responses. I have 15 responses. I'm up to 16 responses. I'm curious what the other 7 of you are doing. Go to your pair deck tab and drag your star to where you think the correct answer is. 17 responses. Let's see. Okay, most of you have 9, 9. Okay, and this is the problem we just did together on Desmos. So 9, 9 is correct. If your star is on -4, -7, that is incorrect. You want your star to be on 9, 9. Okay, and I can show you if I typed in -4, -7, where does that come up? That comes up in the white area. So this is a point that is not true for the pink inequality. It is not true for the blue inequality. So it is definitely not true for both. All right, so that is not the solution. The solution is anything that would fall in the purple area. Okay. And so this problem that we just did together is actually right out of your assignment today. It's right out of Delta Math. I just took one of the problems from Delta Math and put it in here. And so you're going to be using Desmos today to solve these problems in Delta Math. Because Delta Math, if you look at the solution to Delta Math, they're not going to show you the same way. They're going to show you an algebraic way to solve it. So they're going to show you an alternative way to solve it. So the way I just showed you is the way that you want to do it. You want to use Desmos. All right. So last interactive slide here. Okay, I want you guys to think. Is it possible for there to be no solutions to a system of linear inequalities? I want you to think about that. Is that possible? Could we have no solution? Could we take 2 linear inequalities and graph them and somehow not have any overlap? Would that be possible? If you think it is possible, what would it look like? Can you draw me a picture of what you think that would look like? If you think that there's always going to be a solution no matter what you do, why is that true? So you can type for this slide, you can draw for this slide, but you do need to respond. Okay, so I'm going to give you a little bit more time on this one. Give you a full 2 minutes, okay? So at 9:55, we'll see what you guys came up with. 2 minutes to go to your Pear Deck tab and put something down. If you want the participation, you have to participate. You don't have to be correct, but you need to put something. Okay, so you should be in your Pear Deck tab, putting something. Oh, I like what Ashley is doing. That looks great. About another minute. Okay, so let's see what we came up with. Look at this. So here we have two linear inequalities graphed, and they're shaded away from each other. Yeah, this is a great example of a system of linear inequalities that has no solution. Okay, these two lines would have to be parallel, and you would also have to be shading away from each other. So you have this big gap area in the middle that it's not a solution for either one. All the solutions for the pink one are up here. All the solutions for the blue ones are down here. There's nowhere where they're both true at the same time. They never overlap. So that is a great example. Yes. For example, y is less than x plus 1 and y is greater than x plus 1. Okay. Yeah, I like that. Because this would be, that's a great example. Let's see what that looks like. I'm going to go to Desmos and show that real quick. Or you're going to put it in. So I'm going to type it in real quick. Y is less than x plus 1. This is a really cool example, actually. I like it a lot. So here's y is less than x plus 1, and then y is greater than x plus 1. Oh, that's so cool. So they're both dashed lines, and they come right up to each other, but they never meet. They never ever meet. So there is no overlap. That's a cool example. I like that one a lot. Who did that one? I'm trying to find that person. Mauricio. That was a really cool example. I like that. Okay, good job. So anyhow, that is the truth. I'm looking for another one that's true. Parallel lines. Absolutely. Yeah, if you have parallel lines, there is no solution. No, because yes, because the solution can be in a parallel line. Okay, so here's one where they're kind of showing it a little bit. Yep, there is the possibility of no intersection. Absolutely. Parallel lines don't touch. Yep, that's right. Maybe. Okay, so the last slide here. Sometimes a system of linear inequalities has no solution, and that happens when the boundary lines are parallel and you're shading away from each other. So you could possibly have, and let me show you what this might look like as well. So say, I'm going to share this one. I have these two lines greater than x plus 3. So a little bit, oops, that's the equal sign. Okay, so here's an example where they're parallel and you're shading away from each other. There's no solution. Now, I could still have parallel lines and have a different symbol. Like instead of, say, less than, I had greater than. I mean, instead of greater than, I had less than. Okay, and then now these lines are still parallel, but there is overlap. Okay, the overlap is everything below the pink dash line. Okay, so it depends on the symbols, but definitely the lines would have to be parallel in the case for it to work. All right, awesome. So what I'm going to do right now, we have 2 minutes left. I am going to stop recording our lesson.